Hey everyone, I'm Sasha, CTO and co-founder of Teleport. Unlike other folks, I actually didn't know it was going to be the starting music, so it was interesting for me. And what makes it easier for me to present at conferences, especially Teleport Connect, is there's a little story I've been going around and telling folks. One of our customers, they're folks from East Coast, and worked with some of them. They're very direct, very polite, but very direct. And when I invited them to CAB last year, actually, our customer advisory board and Teleport Connect, they told me, look, Sasha, we're going to come to the Teleport Connect, but I'll be honest with you, we're not going to be there because of you. We see you every other week on Zoom calls. We're here to talk to other folks who install Teleport, who have the same problem as we do with infrastructure security. So you just got to relax a little bit, okay? And that's what I'm going to do. F's talk was very serious. My talk is not as serious, but I hope I will invite you all to think with me about the problem that I'm going to tell you about. So F focused on infrastructure security, specifically in the context of identity-based attacks. And I will focus on a critical component of infrastructure security, but slightly different one. It's authorization and access control. And let's first take a look at the scope of the problem that we're seeing. We'll look at the limitations of the current technology stack, and then we will also actually go to the demo. And in the demo, I want you all to brainstorm with me a little bit and think about, what do you like? What do you see there? Do you want to join us in that work? So that's, to be honest with you, that's going to be the most exciting for me. All right, let's take a look at the problem. We have a serious problem in authorization and access control. According to the industry research, more than 85% of all data breaches are caused by misconfigurations. And authorization is the most important piece of configuration we can imagine. If we get our foundations wrong, we're risking to basically open our S3 buckets to the public where they can download them. Or we can misconfigure our lower environments. So folks, when they breach them, that sometimes they're not as well defended, can very easily pivot to the higher privileged environments. And that's what's serious about this problem. And some people will go as far as saying that 95% of all data breaches are actually caused by human error, the same error that Ev has talked about. People click on phishing links all the time. They misconfigure IAM policies that accidentally expose secrets, commit them to code. I certainly have done, may have done some of those things in the past. At this point, you might say, looking at all those numbers, okay, Sasha, I'll alert the media, right? People make mistakes. Great. What else is new out there? And I'm going to agree with you. Here's the big reveal. Every time I hear the words human error, immediately in the back of my mind, I think, well, there's got to be bad technology hidden somewhere. And let me give you a couple of examples to illustrate my point. We all are going yearly through corporate security trainings, right? And they always tell us the same thing. Look, be cautious clicking on email links from unknown sources, right? And I personally don't even click on links anymore, right? I just go directly to MIME headers, look at the SPF keyim, look at the domain. If I like the domain, I may go to type it in myself and maybe try to locate the URL. Has anybody else have done that? Maybe there are some folks on the security teams that are, as security conscious as I am. Some of folks on my team actually open email links from isolated VMs, throwaway VMs in the cloud, right? And that may or may not be our VP of engineering. I'm not sure. But here's the thing. We first introduced those email links, and then we're telling people, hey, you got to stop clicking them, right? Well, it just tells us there's something fundamentally broken in email authentication and security. Let's ask ourselves a question. Why do we even tell people to stop clicking on phishing links? Well, as we all know, those links usually lead to phishing portals that are designed to look exactly like the legitimate ones, right? That are designed to steal your password, or even weak second factors like TOTP and SMS. That's why Teleport, once we switched internally to use mandatory phish-resistant MFA, which was not an easy task, right? It's hard to adopt because people, are not always easy to change, right? But we explained it to them, and once we adopted them, phish-resistant MFA as a mandatory step, our red teams could no longer breach us anymore using this method. Not only it in the end improved user experience, you don't need to type password all the time. You don't need to worry about phishing links because WebAuthn is phish resistant. It remembers the domain that it was issued credentials for. But it also completely eliminated this attack vector. All right, let's take a look at another example that is closer to our space, infrastructure space. As you may know, Teleport doesn't implement vaults. We're not using shared secrets, and Dev talked about that. And we often actually face criticism from our customers, competitors that always mention this, and leading security analysts that tell us that Teleport is an incomplete platform without one. But here's the thing, it's not that we can't implement the secret storage. It's just we think that implementing one and storing shared secret there for authentication is fundamentally unsolvable security problem. It's precisely because of the human error, right? Eventually, I will wake up, maybe not having great sleep, and just gonna commit all my secrets to code, and that's the end of it. And that is why, as you all know, we're using different methods for authentication. We're using famously short-lived certificates bound to the user identity or the device identity using Face ID, Touch ID. For device identity, we leverage TPMs and secure enclaves and HSMs. But we also use IAM in the cloud. We also actually go as far in some of those cases with some of the providers that are called Kerberos, exactly for the same reason. We want to completely eliminate this attack vector, and we want to improve user experience. Okay, let's talk about this type of thinking and apply it to the problem of authorization policies. This is the best picture I could find about mainframes. I'll be honest with you, might not be the best one. But basically, let's imagine that we are all stuck in the mainframe era of access control. It means that every time when we change something in our authorization and access policies, we have no way of knowing the side effect until it's too late. We might have just locked everybody out. We definitely have done that at Teleport. Or even worse, might have exposed some data to the public, which we haven't done at Teleport, thankfully, but we could have. Our feedback loop with access control and authorization policies is measured in minutes, sometimes hours. When you run Terraform apply, how long does it take you to see the result? And that is a serious issue. Let's take a quick survey, actually. So raise your hand if you have a full replica of your production identity infrastructure. Think users, groups, cloud resources, and policies, and test those policies every time before deploying to production without any side effects on prod. And keep in mind, folks, here are the best, most advanced companies in the world. So I don't actually see anybody. I thought maybe somebody will raise hands, right? Well, I agree with you, right? It's not that easy because the vendors that we're working with are actually not giving us any chance to do that. Okay, now we understand the problem. Let's explore the solutions. And we actually have already solved this problem on other areas of our infrastructure. A lot of change, transformative change in our industry came from famous, or however you call it, infamous DevOps loop. So what is this DevOps loop about? It is about improving customers through having a very good split between coding, testing, operations, deployment, and other phases. So can we apply the same thinking to authorization and access control? What would happen? Well, let's imagine together how this all will look like. Well, we start with planning, right? We need to understand our access space. Where are over-provisioned access patterns in our infrastructure? Where are the most in-demand, most actively used, or most critical parts of infrastructure? Okay, once we've done the planning, using the data, we're going to my familiar and the thing I'm always missing when I'm writing Terraform is a really fast-paced code compile test loop. And in this day, we can also take advantage of the modern linting tools. Some of them are using actually variety of AIs, as you know. We can use generative AI to help us write the policies. Where is all this good technology when it applies to us? So we need coding that's leveraging this. And then we go to the testing phase, where we can actually test our assertions on the real production data. We will then, as we know, publish it, right? We will build the version using Semver release notes. We will use this version, to deploy it using the modern blue-green deployment strategies that give us back pressure, that give us error rates, that give us ability to roll back. And then we will take a look. We will monitor the situation. We will see where the anomalies are. We will see maybe there is too much access, or maybe some bad pattern emerges where folks are requesting access too much when they shouldn't. And then we go back. We go back to the planning phase from that monitoring. All right, and to demonstrate all this in action, in the best tradition of my presentation, Teleport Connect, we're going to show you a demo. And for this, I would like to invite our lead product engineer, Dave Sudia, to demonstrate our approach.
Okay, so what I'm going to show you today is a very early demo of policy as code. In the past, I was a platform engineer, and I was one of the biggest proponents of infrastructure as code. I started with Terraform and eventually moved to Pulumi. What really excited me about Pulumi was having a Turing-complete language to write infrastructure code. Being able to create constructors and delve into more complex models for generating infrastructure was a game changer for me, especially since infrastructure is really complex these days. So as I show off policy as code, you'll see why I love working with this feature. To give you a bit of context about what I'm showing today, I've set up a relatively simple environment. We have two teams, the payments team and the inventory team. Each team has dev and prod servers. Additionally, we have Kubernetes clusters for dev and prod environments, which both teams use and have their own namespaces in. Let me navigate to access management and users. Here, you can see we have Pavel and Priya, who are on the payments team, and Ingrid and Ian, who are on the inventory team. This naming scheme is going to help me keep everything straight as I walk you through things. Right now, all these users have a role of no access. When you create a user in Teleport, they must have a role assigned, and we have a role that essentially doesn't grant access to anything. This allows us to bring users in completely fresh. They have no ability to do anything until we grant them permissions using code. So let's dive into the code. I've prepared some files here for the payments team and the inventory team, covering both their dev and prod environments. But let's start with the payments team's dev environment, the happy path. Here, we're using a Go library to define our policies. We're bringing in some users and setting up an access object that we can operate on to provide access. I want to give access to Pavel and Priya to any server or node that has the labels env, dev, and team payments. Since this is the dev environment, I'm going to give them admin access. I also want them to be able to log in as themselves, and I'm allowing that. We could also set up deny rules, but we'll focus on the allow rules for now. So here's the most exciting part for me. We can write tests. As a software developer who started out in quality engineering, I love writing tests. So I'm going to assert that Priya should be able to access the nodes with those labels as herself. I'll assert that she should have admin access to those nodes. I also want to make sure that she cannot use the admin login in the prod environment. I want to make sure she can't log in as Pavel. And additionally, I'll ensure she can't log into the inventory team's servers. For the Kubernetes cluster, I want her to access the dev environment cluster. If you're familiar with Teleport's Kubernetes access feature, this will make sense. If not, we have the ability to set Kubernetes resource rules inside of Teleport. Essentially, you can give someone cluster admin or system masters access, but then restrict what they can actually do through Teleport policies. So here, I'm saying match the group cluster admin, but only allow her to do things in the payments namespace. Then I'll make a similar assertion for that. This is all really neat. We can write code to define our policies and assertions, but that's not actually what excites me the most. That comes after we run this code. So I'll run the code. When I run it, I'm given the option to see the policies that are about to be created, show policies. Let's pick that choice. All right, I'm getting some text here that explains what I'm creating. We're setting up admin access with login self to these nodes and so on. But what I really want to do is visualize these policies. Storing things in code is great, but it can be hard to keep hold of a complete mental model, especially with policies. This is where mistakes often get made. It can be challenging to determine if you've actually given people the correct permissions you intended to give. The assertions help with that, as we'll see in a minute, but I want to see what I'm creating, so I'll choose to visualize the policy. This brings up Teleport Access Graph and instantly shows me what permissions I'm about to grant. On the left, we can see Pavel and Priya as our users. On the right, we have the resources, the payments dev server and the dev Kubernetes cluster. In between, we see the roles being created to facilitate this access. You'll notice there are actually 3 roles connected to the payments dev node. 1, 2, 3. That's because we have Pavel's role that gives him access as himself, Priya's role that gives her access as herself, and a shared role that grants both of them access as the admin login. Similarly, we see the roles that give them access to the dev Kubernetes cluster. On the right side, we have our assertions, and we can visually confirm that they're all passing. This helps me ensure that each role I'm setting in my policy is working as intended. For me, seeing this was the aha moment of policy as code combined with Access Graph. I thought, oh wow, I don't have to hold all this code and domain knowledge in my head and try to reason about it. I can just see it. Now, as a developer, another aspect that really excites me is the ability to do test-driven development for policies. That's what we're going to do next. Here I have a file for the payments team's prod environment. I have a kind of placeholder policy because we need at least one actual policy to run this at the moment, but I've written all these assertions, the same ones from before, but adjusted for production. In this case, I'm not giving them access as the admin user. I'm denying it here. And there are other differences suitable for the prod environment. So let's run the same command as before, but for the prod environment. Here we can see that I have assertion errors now. I've stated that Priya should be able to log in as herself into the prod server, and that she should have viewer access to the prod Kubernetes cluster. But because I haven't actually written those policies yet, I'm getting instant feedback. The power of this is having the same quick feedback loop for policy as you do for any other kind of code. As you're doing this, you should be able to write your assertions and see them fail initially, red, and then write the code to make them pass, green, just like in test-driven development. So let's do that next. I'll go back and uncomment the policies for these assertions. Comment out the placeholder policy, and I'll rerun the code. And now I've executed my policy successfully. Let's visualize these policies to see what we've done. We can see that all my assertions are passing now. I've given them the appropriate access. You'll notice we're seeing one less line because we're no longer giving admin access to the node. I can see that I'm giving access to the Kubernetes cluster as a viewer, and I can visually confirm all my information before I apply it. To come back to the idea, our options here are show, visualize, promote, and purge. If I really wanted these policies to go live, I could promote them and they would be applied within the cluster. And this is a key point. I want to be able to do all this without actually making it live. I want to see my potential changes to the production environment before I apply them, just like I would with my infrastructure. And now I have that ability. Next, let's explore the power of these assertions in catching mistakes. I've written policies for the inventory team. We're going to pretend that I forgot to include this line here. I'm giving them access to all of their inventory resources, but I've forgotten to set the env dev environment label. I've written these assertions, and one of them states, make sure to deny production access as admin. So let's run the code for the inventory team's dev environment. Great, oh shoot, what did I do? Oh no, I've got a failing assertion around prod access. Let's visualize this to get a clearer sense of what's going on. Here I can see that I've accidentally given them access to the production server as admin. That's not what we want. Let me go back to my code and fix the policy. I'll add the missing env dev label to ensure they're only getting access to the dev environment, and now I'll rerun the code. And now we're good. My assertions are passing. I could visualize it again, but you get the idea. This is super powerful. I have that instant check of my assertions against the policies now. But here's where I really see the power in this feature. The visualization helps catch when you've written incorrect assertions. If you're an engineer, there's undoubtedly been a day when you've written bad tests. I know I have plenty of times. That's where the visualizer in Access Graph becomes incredibly valuable. Let's suppose I run the code for the inventory team's prod environment, but I forget to set the team inventory label. Additionally, I forgot to write an assertion to deny access to the payments team's resources. So I'll run my code. I hit enter, and all of my assertions pass. Things look good, but let me check it in the Access Graph real quick. I'm going to look it over. Great, all my assertions are passing. There's Ingrid and Ian, and wait, why is the payment server on here? I've accidentally given the inventory team access to infrastructure they shouldn't have access to because I forgot to include that assertion. So I'll go back to my code. I'll add an assertion to ensure that they don't have access to the payments team's resources. If I run the code now, the assertion would fail, alerting me to my mistake. Then I can correct my policy accordingly and run it again. My assertions all pass now, which is great, but I'm trusting myself less because they just passed a minute ago when there was a mistake. So I'm going to check it one more time in Access Graph. Okay, great. The payment server is no longer accessible. This demonstrates how the visualization tool can catch errors that might slip through your assertions. To wrap things up, we've seen how policy as code allows you to define and manage access policies through code, write assertions for those policies, and use visualizations to both better understand what you've written, examine your policies before they go live, and catch mistakes that might otherwise go unnoticed. This is a significant step forward in managing complex systems effectively and safely. Thanks for watching.
So, again, this is early days, but I think hopefully we've shown the promise of this. And if this excites you, please talk to us about it. And I'm going to have Sasha come back up because I'm sure he's going to be able to answer some questions for y'all. But thank you so much for watching, and have a great rest of your day.
What I want to talk about next, as a wrap-up, is as you have seen, this access control loop in action. Let's talk about the future of it and what are we planning to do with it. What we've just observed, right? There's a missing plan, code, test, release, deploy, monitor loop that we've just uncovered through that exploration and live demo. And we're planning to introduce it for access control, for Teleport, and for systems beyond Teleport. As you all know, if you have tried Teleport Policy, the product that you've just seen part of, so this is the new feature of Teleport Policy, our existing products. We're planning to cover this for the entire infrastructure that you are operating, AWS, IAM, GCP, Azure, even custom infrastructure that you need to govern access to, including Teleport. And we will be introducing this functionality a little bit later this year. It's a part of, as I mentioned, of the existing products, Teleport Policy. And what I'd like to do, I would like to hear from you if you decide to join us as a design partner. What is important for you here? What's missing? What do you want us to focus on? As a design partner, you will get an opportunity to influence the roadmap. So folks who worked with us as design partners, they know that the engineering team that actually builds this will join you for the live brainstorming session. We will get your highest priority roadmap items and we will bake them into the product by the time it goes live. So that's what's exciting about it. And folks who went through the design partnership program for Teleport Policy itself as a product, I think have good things to say about it. So if you decide to join us as a design partner, just send me an email, sasha@goteleport.com, or reach out to your account manager. We will connect and we will talk about Teleport Policy, part of access control. We are playing with the name, so I was curious to hear, do you all like the name Policy Ops? If anybody likes this name, raise your hand. All right. It just tells me how bad am I with naming. All right, we'll work on it. We'll work on it. Right. Thanks, folks. I really appreciate your time. Yeah, we'll see each other talking and discussing access control, security, identity security. Thank you so much.